Dear students, good morning, students. Today we'll discuss last long answer from thermodynamics, Carnot engine. Explain reversible, irreversible process with Carnot engine. This is the last LAQ for this upcoming supplementary examination. This is the sixth question. Total 5 questions over. This is the sixth. Explain reversible, irreversible process with Carnot engine. Okay. So reversible and irreversible. Here, this is the question they're asking. Explain reversible, irreversible process with Carnot engine, Carnot theory. First, reversible process. Reversible process with example. Irreversible process with example. Carnot engine with explanation part. Expression for efficiency. Efficiency in Carnot engine. This is the last long answer. Total 6 LAQs you are reading. Out of 6, 5 LAQs over. This is the last question from thermodynamics. Okay, from thermodynamics. See, now reversible process. What is the reversible process means? Example, you take ice. Ice, nothing but solid state. On heating, ice convert into water. On heating, ice convert into water. Solid state to liquid state. Again, on cooling, water convert into ice. This is called reversible process. Reversible process means a process retraced back. A process can be retraced back in opposite direction. So a process can retrace it back. That is reversible process. Ice convert into water. melting of ice, water convert into ice, fusion of water. Just one word, reversible process, one statement in one line, then after one example. So I'm writing what is the reversible process means like this. See, a process can be retraced back. Just one single word. A process can be retraced back. A process again coming towards back position. That is reversible process. Morning, you are coming from your house to college. Evening hours, again you are going from college to house. That is called reversible process. So, reversible process statement, a process can be retraced back. Example, melting of ice, comma, fusion of water. Example, compulsory. So, reversible process, definition over with one example. For this total statement and example, you can get 1 mark. 1 like that, total 8 marks. You are coming individually. So, reversible process over. Next, irreversible process. Irreversible process. See, here a process can be retraced back. Quite opposite. A process cannot. Again, one more example. See, for example, student, you take in our daily life, we are watching milk, milk. By using milk, we can get curd. Milk convert into curd. But curd, again, milk means impossible. You don't try this example, just example I am giving. A process can retrace it back. That is previous case. A process retraced back. Now present, a process cannot retrace it back. Diffusion of gas, explosion of bomb also irreversible process. So work done against friction. All this one examples for irreversible process. Here, what is the statement means? A process cannot, here can be, cannot retraced back. Retraced back. Okay. Just a small word. Can be retraced. Cannot retrace it back. Example, write physics, thermodynamics related example. Work done against friction. So, reversible process, irreversible process. What is our topic? Explain reversible process, irreversible process with Carnot engine. What is the Carnot theory? Carnot is person. So Carnot engine, reversible definition, irreversible definition with one minimum one example. A process can be retraced back. One more question is there. One more example is there. Actually, that one intermediate secondary case. Seebeck effect, Peltier effect. Like that, all effects, that one intermediate electricity, thermal electricity concept. Compare that one, you go examples from thermodynamic zone first year. A process can be retraced back. Reversible. Example, irreversible process. A process cannot retrace it back. Then after next, Carnot engine. So here student, Carnot engine. What the Carnot engine means? An idle engine, a reversible heat engine. heat engine. How heat engine different from refrigerator? This question came in recent annual examination student. So what is the Carnot engine means? Ideal engine. Anywhere ideal word coming in physics, ideal gas, ideal engine. In second year, ideal transformer, ideal cell, ideal string, ideal block body. Anywhere ideal word coming in physics, ideal nothing but imaginary. Ideal means imaginary. So Carnot engine, what is the Carnot engine means? A reversible heat engine. Otherwise, an idle engine. An idle engine working in between two different temperatures. One idle engine working in between two different temperatures. That is idle engine. We are calling Carnot engine. In Carnot engine, what is the derivation of efficiency? Expression for efficiency. Now I am giving explanation. So what is the Carnot engine? Here an ideal engine working in between two temperatures. In between two temperatures. This one Carnot engine student. For this one, indicator diagram. What is the indicator diagrams here? Here students, x-axis, y-axis, P1, V1, T1. At A point, B point, C point, D point. At A point, pressure P1, V1 is the volume, T1 is the temperature. So ideal engine means generally like this. See, one source, one working substance, one sink. Source, hot body, sink, cold body, working substance, nothing but engine. Like that, three different parts present. That's why we are writing initially at A point, pressure P1, V1, T1. Next B point means P2, V2, T1 only. Sometimes students, they are writing in tension direct T2. Here T1. What is the reason means? In this situation, isothermal process coming. So temporarily, first focus on this concept, why we are writing this one. I will give you individual explanation. A point, P1, V1, T1, pressure, volume, temperature. Like that, B point also over. C point means P3, V3, T2. D point means P4, V4, T2. So these are the coordinates or points from different situation. Here, what is the indicator diagram means? Pressure on y-axis, volume on x-axis. That diagram we are drawing a graph in between pressure and volume, a graph plotted in between pressure and volume. Pressure on y-axis, volume on x-axis. What is the graph? Indicator diagram. So student, A point P1, V1, T1, B point P2, V2, T1, C point P3, V3, T2, D point P4, V4, T2. In this one, total four different working coming, four different situation. First, previous case, the question starts from reversible, irreversible process. Starting, you are writing reversible process definition. A process can be retraced back. Irreversible process. A process cannot retrace it back. With examples. One is the reversible process. Second one, irreversible process. Then after, Carnot engine. What is the Carnot engine statement? An idle engine, a reversible heat engine, a reversible engine, an idle engine working in between two different temperatures. So two different temperatures. Better you write different. That's why we are getting how many temperatures means the situation T1 coming, here T2 coming. Two different temperatures, one system working. What is that? Carnot engine. From this total indicated diagram, now we are writing what is the expression for efficiency. Efficiency of Carnot engine. The derivation part coming from this indicated diagram. Total 4 coordinate there, 4 different points. A, point number A. A. Here, student, point A here. A to B, pressure changed, volume also changed, temperature same. Temperature same, remaining all parameter changes means that is the isothermal process. You are reading in physics cum chemistry. Temperature remains same. Remaining parameter changes means from A to B, isothermal process. Again in isothermal process, it is going forward. That's why we are writing A, isothermal expansion. Isothermal expansion. One is A. Otherwise, AB also write, no problem. From A to B, isothermal expansion. Now, work done. Work done in between A to B. What is the expression for work in isothermal expansion? Generally, what is the work done formula in isothermal process means N or T log base E V2 by V1. This formula from thermodynamics, from physics and chemistry are reading. So from this one we are writing work done W1 equals to N or T. T stands for temperature. What is the temperature here? T1. So N or T1 log base E final volume by initial volume V2 by V1. Here also final volume by initial volume, student. So we are writing this expression from isothermal process. This one we are writing Q1. Why we are writing Q1 means here I am giving diagrammatical explanation. First, Carnot engine. Total 4 different work done equations coming. First one is the work done in between these two. AB. Second one is the work done in between BC. Third one is the work done in between CD. Fourth one is the work done in between DA. 2 process expansion coming. 2 process compression coming. So first A to B work. First I am giving complete explanation, student. Then after shortcut explanation, yesterday I gave SHM concept also, short method. This question within 5 to 6 steps you are getting answer. Before that one you listen what are the individual steps with individual work done equations. Isothermal expansion. Why we are using that? Isothermal means temperature same. That's why we are saying isothermal process. AB. This equation from isothermal process. Why we are writing Q1? There is a reason, small reason. I will give you one diagrammatical explanation. Second, BC. In BC, pressure changed, volume changed, temperature also changed. Meaning, temperature, pressure, volume, every parameter changes. That is nothing but adiabatic process. So in this one, isothermal process is there, adiabatic process is there. This is isothermal expansion. This is adiabatic expansion. Now see our second one. BC. Adiabatic expansion work W2 equals to NR by gamma minus 1 T1 minus T2. What I'm giving that isothermal process, adiabatic process, that the individual 4 marks derivation students. 4 marks when I'm teaching, I will give explanation. First of all, what is the adiabatic process? Formula means C. W equals to NR by gamma minus 1 T1 minus T2. C. W2 equals to NR by gamma minus 1 T1 minus T2. See, in previous, see, like this. P1, V1, T1, P2, V2, T1. Temperature same. Isothermal expansion. Next, BC. Temperature change. Adiabatic expansion. Again, CD. Temperature same. Isothermal compression. Because of this arrow mark, see. 2 arrow mark here, forward, 2 arrow mark here, reverse coming. Because this is the cyclic process. Closed loop meaning. Next, DA. Next, CR. So AB means isothermal expansion, BC means adiabatic expansion. What about CD means isothermal compression, DA adiabatic compression. Just 4 work done. On adding, we can get our last equation. Concept, very easy concept. This isothermal, this reversible process, irreversible process, Carnot engine, that answer looking very big, but very easy answer. First you listen complete answer. Then after I will give you short method, how to write this answer in short way for 8 marks purpose. Over isothermal expansion. Now adiabatic process. Then after isothermal compression. Here. So here better you wait. You go like this. Because 2 ways their formula. W is equal to NR by gamma minus 1 T2 minus T1. See, gamma minus 1 T2 minus T1. This is the formula 1 way of writing. One more is there same. NR by 1 minus gamma T1 minus T2. Both are same representation only. I'm going like this. NR by gamma minus 1 T2 minus T1 student. This is nothing but adiabatic expansion. Now see AB over BC over. Next one more case. CD. This one isothermal compression. Now see here. CD. Isothermal compression. W3. NRT2. Because formula W is equals to NRT log base C V2 by V1. This is our main equation from isothermal process. N, number of moles, or Rydberg's constant. Sorry, or universal gas constant, or intermediate secondary Rydberg's constant. Universal gas constant, everyone you know. This one we are getting from here. Ideal gas equation PV is equal to nRT. Or universal gas constant, the standard value 8.315 joules per mole Kelvin student. This is all constant value. Now, according to our situation, temperature. What the temperature means? T2 is the temperature. That's why we are writing T2. And one more, previous case, this one expansion means V2 by V1 we wrote. Formula V2 by V1. Present we are going reverse. That's why previous case final volume by initial volume. See here everyone. This is the final volume by initial volume. What about present situation means reverse initial volume by final volume. V3 by V4. V3 by V4. So nRT log base C V3 by V4. This is nothing but Q2, equation number 3, equation number 2. Still, I didn't give any explanation related Q1, Q2. Small reason why we are writing for only for isothermal expansion and isothermal compression Q1, Q2. Last, DA nothing but adiabatic compression. This is the last step, student. Almost your answer over. Work done formula you write as usual. NR by gamma minus 1, T2 minus T1. Why we are not writing plus minus means in next step we are writing sign convention with sign convention. See, work W1, work W2. This one plus, this one also plus. What about here? Minus. What about here? Minus. Because of directions opposite. So, total work done, we are writing like this. Total work done equals to W1 plus W2 minus W3 minus W4. 2 in plus, 2 works in minus. Reason that direction. See, 2 direction forward, 2 direction reverse, 2 expansions, 2 compressions. So, W equals to, this is the second equation, student, W2 plus, this is the W4 minus, equation number 4. So, equation 2, equation 4, both are same with opposite sign convention. That's why W2 term, W4 term cancel each other. W1 minus W3. This one only we are writing Q1 minus Q2, student. Now you listen explanation why we are writing Q1, Q2. For first equation and third equation, we got Q1 and Q2. So, why we are writing Q1, Q2 means here, student. This is the source, engine, the thing. See, source means hot body, sink means cold body. First situation, source, Q1 and Q2. From source, engine absorbs Q1 amount of heat from source. It absorbs Q1 heat from source. That engine doing some work. Then after it rejects Q2 heat. In these two situations, students, compulsory temperature changes. Q1, Q2 we are writing means in the situation when temperature changes, that situation we are writing Q1, Q2. You observe in these 4 different situations. In which situation temperature changes means only 2 situations. First of all, P1, V1, T1, P2, V2, T1. In this gap, isothermal process, this is the adiabatic process. Again, this is an isothermal process. This is an adiabatic process means here P1, V1, T1 means that engine absorbs Q1 amount of heat means this is here you treat this amount of work done nothing but Q1 heat. This is the engine and this is the source and this is the sink. First situation, engine absorbs Q1 amount of heat means from source. This is isothermal process. Temperature remains constant. This work done you treat Q1 amount of heat. Q1 amount of heat absorbed by the engine. This first situation over. Second, adiabatic process there. Then after one more situation, here isothermal compression, nRT2 here and first case temperature remains same. That's why we are writing here Q2. So Q1, Q2 already we wrote for equation 192 and one more W1, W3 means instead of Q1, Q2, we are writing this one, isothermal process, adiabatic process values, what we wrote, cancel each other because of this is the plus value and this is the minus value, student. Now, work equals to Q1 minus Q2. From this work equation, we need what is the efficiency of Carnot engine. This answer in 6 steps we are getting, but I'm giving complete explanation. Then after, in short method, how to write this Carnot engine in short method, I will give explanation. This is the work done. Our topic from this indicated diagram, that graph, what is the expression for efficiency? What is the efficiency notation? Here. So finally, isothermal process work done, adiabatic process work done, total isothermically and adiabatically system going. That's why we are getting 4 equations, 2 from isothermal process, 2 from adiabatic process. In adiabatic process, 2 work done cancel each other, remaining 2 isothermal process. Here, efficiency here denoted with eta equals to work done by heat observed by the engine. This one eta, few members calling neta because looking like N model. Eta, that is Greek letter. Eta equals to ratio between work done by the engine by heat observed by the engine. Just now we got work formula in terms of Q1 and Q2. Work equals to Q1 minus Q2. This one we are writing like this. Both are same because Q1 cancel. Q1 balance for only Q2 denominator term. So eta equals to 1 minus Q2, meaning last equation, third equation, nRT2 log base E, V3 by V4. nRT2 log base E, V3 by V4. This is Q2 by, only by belongs to here only. First, nRT1 log base E, V2 by V1. This is the Q1 and Q2 formula, student. NR cancel. Log base E, V3 by V4. Log base E, V2 by V1. Here one condition, PV gamma minus 1 equals to constant. In adiabatic process, 3 process there, 3 different formulas. TV gamma minus 1, what is the meaning of this formula? Means this formula indicates that in diagram, you observe diagram, say 2 situation forward, meaning for example here in cyclic process, 2 situation volume increased, again 2 situation volume decreased, meaning what is the change in the volume? Means 0. There is no change in the volume. So TV gamma minus 1 equals to constant means, actually here we are doing calculation. What we are getting means V3 by V4 equals to V2 by V1, meaning this log basis step and this log basis step both are same. 1 minus T2 by T1. Why we are taking this one cancel means depend on that TV gamma minus 1 equals to constant, change in the volume always equals to 0 there. So NR by NR cancel. What is the remaining step means? Eta equals to 1 minus T2 by T1. This is the derivation of efficiency of Carnot engine. So eta equals to 1 minus T2 by T1. This is the long derivation part for Carnot engine with reversible, irreversible. All members, now you listen step by step. I am giving explanation. Next, within 6 to 7 steps, how to write this answer. Short method, I am giving explanation. Reversible process, single line. reversible process. A process can be retraced back. One statement with one example. A process can be retraced back. Melting of ice, fusion of water. This one example. Irreversible process. A process cannot retrace it back. Explosion of bomb, diffusion of gas, work done against friction. Any one example. Then after student, Carnot engine statement. An idle engine working in between two different temperature. Actually, in this one, which one working substance means idle gas. Carnot is suggested when Carnot engine, when idle engine. Possible means he suggested few situation, few terms. I will give you last after efficiency explanation. That one not related to our IP examination, but I will give you explanation. Carnot engine means statement. A reversible heat engine. Otherwise, an idle engine. An idle engine working in between two different temperatures. That is Carnot engine. For this Carnot engine, what is the expression for efficiency? Eta equals to question mark. Diagram. Your graph, indicator, diagram, indicator, graph, pressure, volume. Pressure on y-axis, volume on x-axis. We can get one graph, that is indicator diagram, student. In this one, temperature constant. This situation, work done in isothermal process. Isothermal process, total 4 process you are reading in physics, chemistry. Isothermal process, adiabatic process, isochoric process, isobaric process. So here temperature same in between A comma B. That's why we are going work done in AB isothermically. We are writing isothermal expansion, equation 1. This equation 1, 2, 3, 4 from remaining concept, work done in isothermal process, work done in adiabatic process, individual formers expression, that one. Now AB work done over this one. Engine absorbed Q1 amount of heat. We wrote equation 1 in terms of Q1. Same like that, adiabatic expansion, NR by gamma minus 1, T2 minus T1. So second equation, fourth equation, both are same, quite opposite. This is the adiabatic expansion, this is the adiabatic compression. What about third one means CD? Again temperature same, but we are going reverse. That's why we are writing nRT2 log base C V3 by V4. So engine rejects Q2 heat to the sink. This one 2, 4 gets cancelled each other here because of one plus value. Second one is the minus value. What the remaining balance means? Q1 minus Q2. So work equals to Q1 minus Q2. Eta. Efficiency equals to work done by heat absorbed by the engine. Work done by the engine by heat absorbed by the engine. This one we are writing Q2 by Q1. NR log base C terms also cancel each other. Effect of this PV gamma minus 1 is equal to constant. In this one again enlarged expression, just this word enough for this volume. Terms cancel each other. Then after 1 minus T2 by T1, student. This is the efficiency of Carnot engine. Okay. Say here all members say this one, how we are getting 100% mean, students. T2 equals to 0. This one not related to our examination, but what is the importance of this efficiency equation in Carnot's theory? I am giving explanation. Total 3 situation. Carnot said 3 situation possible means construction of idle engine possible. One is working substance is idle gas. Working substance is idle gas. Practically idle gas not there. Idle gas means imaginary gas. Idle gas means in all situation which obeys gas laws. Idle gases not there. Only we are having real gases. So student, idle gas. First situation, working substance, ideal gas, Carnot engine possible. Construction of Carnot engine possible under three situations. One is ideal gas, practically not possible. Second one, 1 minus T2 by T1 means T2 equals to 0 Kelvin. What the T2 is equal to 0 Kelvin means? This is the source, this is the engine, this is the sink. When sink temperature 0 Kelvin, sink we are keeping at minus 273.16 Kelvin. At 0 Kelvin temperature, we are keeping construction of ideal engine possible. Practically 0 Kelvin, nothing but anything does not exist. He said, if temperature of sink 0 Kelvin, construction of ideal engine, Carnot engine possible. That one practically not possible. Third one, when we can get eta is equals to 100% means T1, temperature of source nothing but infinity. If we are keeping source temperature infinity, Carnot engine possible. So this three condition practically not possible. The students. So this is the last question from intermediate first year, long answer. Total 3 long answers you are reading. 3 long answers with problem. This one now within few steps, how to write this Carnot engine with reversible, irreversible process in short way. I am giving in only 1 page explanation here. Previous answer, present answer, both are same. Just you are skipping unnecessary steps. First, reversible process. Dear student, reversible process. Wait, more small steps I will write because reversible process. Just I need one word only. That's why I'm writing somewhat small font size. Reversible process. A process can be retraced back. Only one word with example. So here we are writing retraced back with example, student. Melting of ice, fusion of water, that one. Next, irreversible process. Here, cannot retrace back. Light. A process can retrace it back. That is the first case, reversible process. Next one, irreversible process. A process cannot retrace it back. Student, again your example, like previous only work done against friction. Write any example related to our first step topic. Then after, Carnot engine. Carnot engine. Carnot engine means idle engine. And idle engine working in between 2 different temperature. Idle engine working in between 2 different temperature. All of you see. Then after, diagram, indicator diagram. Forward, reverse. A, B, C, D. P1, V1, T1. P2, V2, T1. P3, V3, T2. P4, V4, T2. All this one, pressure, volume, temperature, students in different situation. Now say, number 1, work done in between AB. What is that isothermal process? W1 equals to nRT1. What is the formula? Log base E V2 by V1, equation number 1. This one we are writing in terms of Q, heat absorbed by the engine, heat given by the source towards engine. One equation. Second one, work done. AB over means BC. NR by gamma minus 1, T2 minus T1, equation number 2. Now third one, work done. Isothermal compression, work done. AB over BC over CD, reverse. NRT2 log base E V3 by V4, equation number 3. Last equation, student, again work done, everywhere 4 work done with different situation. W4, this is nothing but Q2. So what is the W4 meaning? Adiabatic process, same equation we are writing, T2 minus T1, student, fourth equation. Here, previous and present, just you concentrate on previous and present. What are the variations? Both are same answer, same 8 marks, but this one short method. Total 4 different work done over. Now I'm writing total work. Total work means, student, W is equals to W1 plus W2 minus W3 minus W4. W1 means Q1, W2 and W4 cancel each other. Work is equals to direct Q1 minus Q2 because we got W1 minus W3 direct. Now efficiency. Eta equals to work done by the engine by heat absorbed by the engine equals to Q1 minus Q2 by Q1. Direct we are writing 1 minus T2 by T1. In bracket you write this word TV gamma minus 1 equals to constant, because effect of this step after cancellation we are getting our that derivation part. See, previous derivation, present derivation 100% same. Just what they are watching annual examination, otherwise upcoming supplementary examination, they are watching scheme of evolution point, student. This one, first statement, reversible process definition, example over. They are watching reversible statement with example, irreversible process with example over 2. Then after Carnot engine, this diagram, indicated diagram, graph. Then after all 4 work done equations, they are watching this steps only. Then total work done, we got capital W is equals to Q1 minus Q2. That one only 1 minus T2 by T1. This condition compulsory. TV gamma minus 1 is equal to constant. Previous we wrote cancellation term, that one all our convenience we are writing. So this is the short way for Carnot engine, reversible, irreversible process. Once you check, one is the X, one is the Y. So, students, successfully LAQs over. I finished 6 LAQs. One more time and last time I'm giving explanation LAQ, total 6 LAQ coming from 19th bit, 20th bit, 21. This is the last LAQ from thermodynamics. So tomorrow onwards, I'm going to explain 4 marks question. Before that one more time focus on 19th bit LAQ. How many questions getting? 20th, how many questions? 21, how many questions? Total 6. Every student you read 6 LAQs enough. You focus on VSAQs, come SAQs, 6 LAQs enough for upcoming supplementary examination. First 19th. Why we are writing 19? Why I am writing this 19 means only one reason. Annual examination paper, total 10 VSAQs they are giving. So VSAQs 10. Then after 11 to 18, from 11 to 18, you are getting SAQs. Total 8 SAQs. From that one, 2 choice, you are writing any 6. So 11 to 18 SAQs over. 19th onwards LAQ. That's why I'm writing this 19th bit. If you remember thinking 19th means 19th question, not 19th question. Annual examination comes supplementary purpose. Annual exam over, always annual word coming. Supplementary examination come betterment purpose. 19th bit, how many question chance means 2. Question number 1. Here, law of conservation of energy. Freely falling body. This one, freely falling body with bullet problem. Bullet problem 5400 watts. First question, law of conservation of energy, freely falling body, bullet problem 5400 watts. In this one, second question, define work kinetic energy, work energy theorem, work energy theorem with 2 questions, student. One is the power of motor 15 kilowatts, second one 166, approximately 170 horsepower. Total 2 problems for work kinetic energy, work energy theorem. From these 2, one coming. 19th bit, this one. 20th. Derive expression for time period of simple pendulum. Simple pendulum. T is equals to 2 pi under root of L by G. For this one, 3 cases. Ticks. Seconds pendulum. 7 by 16 meter decrease problem. So, this is the 20th first question. Next, yesterday question. Define SHM, particle motion, SHM with respect to diameter in circular path. So, student, for this one also problem, phase difference 5 by 4. 19th bit 2, 20th bit 2, 21. Newton law of cooling. Newton law of cooling, surrounding temperature. Surrounding temperature problem 28.3 degrees Celsius. Today question lost, reversible, reversible, irreversible. Reversible, irreversible process, Carnot engine, Carnot engine. So student, from this 6, minimum 2 questions you are getting for this upcoming supplementary examination. Total 6 questions I gave in short method also. This 2 from work power energy, this 2 from oscillation, this 2, first one from thermal properties of matter, second one from thermodynamics. You treat thermodynamics only. Work power energy, oscillations, thermodynamics. From this 6, 100% you are getting 2 questions. So this 6 LAQs for upcoming supplementary examination. Is it clear, student? So we'll continue tomorrow.